Hi, grade 11 and 12. Welcome back to this session. Thank you very much for joining me once again. We are still continuing with Euclidean geometry revision, and today we're going to be covering theorem number 7 and 8, which focuses on tangents. Okay, theorem number 7. It states that if you have a tangent, right? Remember we talked about the tangent in session 1 when we were doing key geometric basics, and we said that a tangent is a line that touches a curve at one point, right? Meaning that ABC is a what? Is a tangent, right? So this theorem states that if you have a tangent and you have a radius, what will happen is that that tangent will always be perpendicular to the what? To the radius at the point of contact. Okay, meaning that we can see that our OB is our what? Is our radius, and it intersects with the tangent at point B, meaning that at that point of contact, that tangent will be perpendicular to the what? To the radius. As you can see in this diagram, it is drawn that angle B2 is equals to what? 90 degrees, or rather angle B1 is what? Is 90 degrees. So in other words, if ABC is a tangent to the circle at B, right? You don't just see a line being drawn and you start and your radius and you start to say they are perpendicular. No. Very, very key condition. You must be told that this line is a tangent, right? That's the first key. Then you'll always know that, oh, if I have a radius, that radius will always be what? Perpendicular to the tangent at the point of contact. Okay, so meaning that our angle B1 will be equal to angle B2, which will be equal to 90 degrees. And our reason that we give, it's a radius perpendicular what? Perpendicular tan, standing for tangent, right? Or someone can choose to say tan perpendicular rate. You can choose any of the two reasons, right? The method of arrangement there does not really matter. Okay, so that's our theorem 7. Very, very important, the converse theorem. So you'll notice that all converse theorem are really very important when it comes to proving these kind of theorems, right? I mean, they can just give you a line, right? They can just give you a line which is a tangent, obviously, but they don't tell you that is a tangent, but they want you to prove maybe ABC is a tangent, right? So how will you know? You can just check if there's a radius and that is perpendicular to that line, right? Oh, and we can see our angle B2 is equals to 90 degrees. Therefore, we can conclude that OB is perpendicular to ABC, right? OB is perpendicular to what? To ABC, meaning that we can deduce that therefore ABC is a what? Is a tangent, right? So it's actually a converse theorem of this, to say if a line is drawn perpendicular to the radius at a point where the radius meets the circle, then that line will be called a what? A tangent. Okay. All right, let's quickly take a look at an example. So in diagram number 1, they want you to solve for x, right? So you are given that ABT is a tangent, right? ABT is a what? Is a tangent, right? So because they told us that ABT is a tangent, and we have a line from the center to the circumference, which we know is the radius. What do we know? Radius is always perpendicular to what? To tangent. So we can start by saying angle OBT is equals to what? 90 degrees. Because what? Radius is perpendicular to what? To tangent. That's your reason, right? So it's very easy to solve for x. We can use some angles of a what? Of a triangle, right? So meaning that 35 degrees plus x plus 90 degrees will be equals to 180 degrees by what? Some angles of what? Of a triangle, right? Then we can now go and solve for x. Okay, so when you solve for x, you're just gonna take transpose 90 and 35 to the other side, and you'll get your x is equals to 180 minus 90 minus 35, which is what? 55 degrees. So that's actually how we can use that theorem in order to solve some of the problems. Okay, let's take a look at diagram number 2. So in diagram number 2, they want you to solve for x, y, and m, right? We have to solve for x, y, and what? And m. So they told us that ABT is a what? Is a tangent. So this will be your given information in your statement, right? That ABT is a tangent or is the center of the circle and all those kind of things, right? They also tell us that AT is parallel to what? To CD. As we can see in the diagram, this one, AT is parallel to what? To CD, right? So now we have to calculate the value of x, the value of y, and the value of what? The value of m. Okay, so how can we calculate it? It's quite a little bit tricky, but it's quite very simple if we use a relational approach, right? Using the key basics that we started with and all those other theorems that we have covered so far, right? Okay, so for us to solve for x, we know that here we have a what? A radius, and here we have a what? A tangent. A theorem states that a radius is always perpendicular to a what? To a tangent, always, right? But look at this. This cannot really help us to solve for x, right? Because we don't know this angle there, right? Meaning that if we get that angle and we use that 90 degrees, we can go and solve for what? For x, meaning that we have to first get that angle, right? How are we going to get that angle? Very simple. We know that OD is a what? Is a radius, and OB is also another what? Another radius. We said all radiuses are what? Are equal. All radii are equal, meaning that this one is equal to this, meaning that this angle here is the same as what? As that angle, right? We can solve for that angle, right? So how can we solve for it? I can just name it maybe P and P, right? Or rather we can use the alphabet as given to say angle OBD, it's this angle there, is equals to what? Angle ODB, right? Why are we saying they're equal? Because angles opposite equal what? Equal sides. And we have to show them the side that are equal. OD is equals to what? OB, right? Because they are equal radii, right? So if those two are equal, then I can just write 2 angle OBD, right? Because they are the same. So I'm taking this angle and add this, but this is the same as that one. So I'm just writing 2 angle OBD plus 140 degrees is equals to what? 180 degrees. So 2 angle OBD will be equals to 180 minus 140, which is what? 40 degrees. Divide by 2, divide by 2. This angle will be equals to what? 20 degrees. So we've calculated that angle is 20 degrees, and this one is also 20 degrees, right? We can now go and solve for what? We can now go and solve for x, right? Using our theorem, radius is always perpendicular to what? To tangent, meaning that x, we can tell them that angle OBT is equals to 90 degrees. Why? Because radius is always perpendicular to what? To tangent, according to theorem number 7. So our OBT is the same as 20 degrees plus x, right? Is equals to what? 20 degrees plus x is equals to 90 degrees. Then x will be 90 degrees minus 20 degrees, which is what? 70 degrees, right? 70 degrees. So our x there is 70 degrees. Okay, let's go and calculate our value of m and also y. Okay, let's go and calculate our value of y. So to calculate y, we can see that it's an angle at the circumference, right? And we can see another angle at the what? At the center. Immediately when you see this, you must be thinking of theorem number 2. Angle subtended by an arc at the center of the circle is 2 times the angle subtended by the same arc, but at the what? At the circumference, meaning that our angle 140 degrees at the center will be equals to 2 times angle y at the circumference, right? So by the reason angle at what? At center is equals to 2 times angle at what? At circumference. Okay, so because we can see there's an angle at the center subtended by an arc, by the arc DB, the same arc is subtending another angle C at the circumference. So we can just use that theorem 2. Then we can divide both sides by 2. Then we solve for y. Our y will be equals to 140 divided by 2, which is the same as what? As 70 degrees. Okay, so that will be 70 degrees. All right, let's now lastly go and solve for m. So to solve for m, we can see, let me just delete this. We know this is 20 degrees, this x is 70 degrees. So to solve for m, can you take a look at m is on this side, right? We have a radius and we have a tangent. What must come to your mind is theorem number 7 to say radius is always perpendicular to tangent, right? But there's quite a problem here. We don't know this angle here, right? We don't know this angle here, so we have to solve for it, right? But we are given parallel lines. Can you see? There are parallel lines. So what we can deduce from parallel lines is that what? Is that alternate angles are what? Are equal for us to be able to solve for that angle. Can you see? Or rather, let me use a different color for this. We have something like this here. And we have that this angle is the same as this angle, right? They are the same because those lines are parallel. So we can start by telling them that angle A, B, C is equals to y, which is equals to 70 degrees by what? Alternate angles are what? Are equal. And we have to give them the lines that are parallel because CD is parallel to what? To AT, right? Okay, so meaning that we got this angle is 70 degrees. Is very simple to solve for m now, right? Because we know that this 70 degrees that we calculated there plus m will give us what? 90 degrees. Why? Because the radius is always perpendicular to what? To tangent. Okay, don't forget. So our m will be 90 degrees minus 70 degrees, which will give us what? 20 degrees. Okay. Let us now explore theorem number 8 of tangents, right? So this theorem states that if two tangents are drawn from the same point outside a circle, then those two tangents will be equal in what? In length. Very simple theorem. So it says if we have two tangents that are drawn from the same point outside the circle, right? Can you see tangent AB and tangent AC there? They are all from the same point, which is A, outside the circle, right? So it states that those two tangents will be what? Will be equal in length, meaning that we can deduce that tangent AB, or rather line AB, will be the same as what? As line AC, as they have also shown here. And we are required to prove that thing. Okay, so long as they come from the same point, then we can deduce, oh, their length are what? Are the same. Okay, so let us now prove this theorem, right? So we are required to prove that AB is equals to AC, given that the given a circle with two tangent AB and AC, right? So how do we prove this theorem? We're gonna start with what? With our construction. So in your construction, you're just gonna draw the radiuses that goes towards these tangents, right? So I'm just gonna draw a radius from O to C and another radius from what? From O to what? To B. Okay, so that's our construction. Again, after drawing that, we can just draw a line in order for us to form two triangles. Okay, so a line that will bisect that polygon there, or rather that quadrilateral there, in order to form two triangles. So that's what you will write for them in your construction, right? To say join line from O to B and line from O to C and join line O to A. Okay, so let's now go to the proof. How do we now prove this theorem? Remember, we want to prove that AB is the same as what? As AC. So in order to prove this theorem, you actually use congruency, right? You use the idea of congruency that you learned in grade 9. Okay, so how do we use congruency? We know that congruence means that they have the same shape and same size, right? We just need to identify three things that are equal. It can be a mixture of angles and lines. It can be obviously it can be lines only and all that. Then we can deduce that the other remaining ones are also equal, because if you get three things, then you can prove that, oh, these two triangles are congruent. Then if they are congruent, we can also deduce that other sides are also equal, right? Because congruency means same shape and same size. Okay, so in our proof, we're gonna say in triangle AOB and triangle what? AOC, right? We just want to identify three things that are equal. It can be angle and it can be sides, or other sides only, right? Okay, what do we know from those two triangles? Okay, we know that OB is a radius and OC is a what? Is a radius. So we know that OB is the same as what? As OC, right? By what? By equal radii. We know that the radius are what? Are equal, right? All radius are equal. Okay, what can we identify again? Can you see that OA is common, right? OA, line OA is what? Is common, right? It's common on both triangles. It's common on that triangle AOB. It's also common on triangle what? AOC, right? OA is what? Is common. Lastly, we just learned theorem number 7, right? And it says something interesting. It says what? It says a radius will always be perpendicular to a what? To a tangent. We were told that AB and AC are tangents, right? These are the given information there. Meaning that we can deduce that, oh, radius is perpendicular to tangent, radius is perpendicular to tangent, right? Meaning that we can come and now say angle OBA is the same as what? OCA. Because both of them are equals to what? 90 degrees. By what? Tangent, perpendicular what? Radius. Or someone can say radius, perpendicular what? Perpendicular tangent. Can you see? So those angles are the same because they're equals to 90 degrees. So we got our three things. So we can now conclude that therefore triangle AOB is congruent. This is the symbol for congruent. Don't forget. Is congruent to triangle what? AOC. Why are we saying they are congruent? Because we have a side, and then what? And an angle, right? Side, angle. Because of side, angle. Okay. So now that we have proven that these two triangles are congruent, meaning that their corresponding angles and corresponding sides are also what? Are also congruent, or rather are also equal. Then we can now deduce that therefore even the corresponding side AB will also be the same as what? As AC. Why are we saying AB is now the same as AC? We have just proven that these two triangles are congruent, and congruent implies that the two things have the same shape and same size, meaning that if they are congruent, you can deduce that this line AB is also the same as what? As line AC. From what? From congruency. from congruence, because the two triangles are congruent, we can make that deduction. Then we have now proven the theorem that states that if we have tangents from the same point, then those tangents will be equal in what? In length. Okay, let's quickly take a look at this example. Quite challenging, very interesting example. So they want you to find all unknowns in this diagram, meaning that we have to calculate the value of A, we also need to calculate the value of B, and lastly the value of C. Okay, how can we calculate the value of A? Let's start with A. So we can see that A is an angle here, right? And we have a tangent. We are given that AP is a tangent and PT is a tangent. So these tangents are coming from the same point. What can we conclude? They are equal. So we can deduce that, oh, AP is the same as what? As PT. Because they are tangent from what? From same point. Okay, tangent from same point. So what happens now if these two lines are equal? Can you see an isosceles triangle there? Yes, we can see it, right? Meaning that our A will be the same as angle what? Angle T3. Because what? Angles opposite equal what? Equal sides, right? And we can also show them the side that are equal. AP is the same as PT. Okay, so where there is angle T3, I'm just gonna put A. So to solve for A, we can just add up those angles and equate to what? To 180 degrees. Why? Because some angles of a triangle, they are what? They are supplementary. Okay, so 2A plus 50 degrees is equals to 180 degrees. Then our 2A will be equals to 180 minus what? Minus 50 degrees is going to be 130 degrees. Okay, so to solve for A, we can divide both sides by what? By 2. So our A will be 130 degrees divided by 2, which is what? 65 degrees. Okay, so that's how we can use that theorem in order to solve for this unknown. I'm just going to put 65 degrees where there is A. All right. Okay, let's now go and calculate our angle B. So angle B is at the center, right? It's at the center of the circle. And we can now use theorem 2, because if we have to use theorem 2, our B must be 2 angle C. And we don't know our C, right? Meaning we have to use something different. Okay, so we can use, because we know O is the center, OA is a radius, and OT is a radius. What do we know about radiuses? All radius are what? Are equal. Okay, so we can start by telling them that OA is the same as OT, right? Because radii are what? Are equal. Okay, so if that one is the same as that one, what can we deduce? That the base angles, okay, maybe let me use a different color, that the base angles here will be what? Will be the same, right? So the base angles will be the same, meaning that angle A2 will be equals to what? Angle T2. Because what? Angles opposite equal what? Equal sides. We can also tell them the sides that are equal. AO is the same as what? As OT, right? So if those two angles are equal, what does it imply? It means that where there is T2, we can put A2, right? Because it's the same as A2. How can that information help us now? Very, very important. We have to be thinking of theorem number 7. That says what? A radii is always perpendicular to a what? To a tangent. A radius is always perpendicular to a tangent, so that we can solve for angle what? For angle A2. Can you see that? Okay, so that's fairly easy. We have to say angle AOAP is 90 degrees, right? Why? Because radius is perpendicular what? Is always perpendicular tangent. AP is a tangent, so when they meet, they will be perpendicular. Then we can solve for A2 because we have our A2 on this angle plus what? Plus 65 degrees is equals to what? 90 degrees. Okay, so 90 degrees minus 65, it will give us what? 25 degrees, meaning that our A2 will be 25 degrees, right? So where there is A2, I'm just gonna put 25 degrees. We have already said A2 is equals to T2, meaning that also there we can put 25 degrees and go and solve for our angle what? Our angle B. Can you see it's very, very important that you should be recalling those theorems that we did, right? To say radius is perpendicular tangent, thinking of the geometric basics that we started with in our session 1. All those kind of knowledge has to be all conceptualized and integrated within this question, right? Hence, maybe most of the learners find this topic quite tricky because you have to use a relational understanding approach to connect different ideas from our lesson 1 till this lesson. All right. Okay. So we can now go and solve for our angle B. We have a triangle there and we are just left with B. So we can just say B plus 25 plus 25 is equals to what? 180, because these are some angles of a what? Of a triangle. We know that some angles of a triangle, they are up to 180 degrees. Then our B will be equals to 180 minus 50 degrees, because 25 plus 25 is 50. Then our B will be equals to what? 100 and what? 130 degrees. Can you see now? We have finally solved for B. Okay. So let's go and solve for our C. Okay. So to solve for C, it's going to be quite simple because we have our B, which is 130 degrees, right? If I still recall properly, our B is 130 degrees. Okay. So it's an angle at the center. What do we know? Is 2 times the angle subtended by the same arc, but at the what? At the circumference. Meaning that 130 degrees will be equals to 2 times angle C, right? Because it's angle at what? At center is equals to 2 times angle at what? At circumference from theorem number 2. Okay. So we can now go to and solve for our C. We just divide both sides by 2. Then our C will be equals to what? It will be equals to 65 degrees. Is it 65? Let me quickly check. Yes, it's going to be 65 degrees. So that's basically how we solve for C. We actually used our theorem number 2. All right. Okay, grade 11 to 12s. Thank you very much for joining in this lesson. Thank you very, very much for your time. I hope you learned something. Coming up next is our last theorem. It's theorem number 9, which is going to be our last theorem and probably our last session. We don't know if maybe we'll continue and maybe just look at some past papers and just try to help you to see how they can ask you all this theorem all together. Okay, otherwise that's all for today. Thank you very much. Enjoy the rest of your day and goodbye.